Dawn breaks over the Solomon Islands, November 1942. A Japanese reconnaissance pilot climbs through scattered clouds, his camera steady against the cockpit frame. His mission is routine: photograph American positions, return to base, develop the film. But when the images emerge in the dim light of the intelligence tent, routine dissolves into something else entirely. Something impossible. The officers gather close, squinting at the grainy photograph spread across the wooden table. Yesterday, this stretch of coastline was raw jungle and coral sand. Today, a fully operational airstrip cuts through the landscape like a surgical scar, complete, functional, and already dotted with American aircraft. One commander traces his finger along the runway's edge, as if touch might confirm what his eyes refuse to believe. The photographs don't lie, yet the timeline makes no sense. How do you build an entire airbase in the span of a single night? The question hangs in the humid air, unanswered. It will be asked again and again in the months to come, in Tokyo war rooms, in engineering academies, in the private journals of men trained to understand construction and yet confronted with something that defies every principle they've learned. The Americans have done more than capture territory. They've bent the rules of time itself. This isn't just about steel and earth. It's about a fundamental shift in how war is waged, a transformation that would ripple across every island, every battle, every strategic calculation for the remainder of the Pacific campaign. While Japanese engineers had spent months, sometimes years, building permanent airfields with concrete and careful planning, the Americans were landing on hostile beaches and launching fighters before the sun completed its arc across the sky. The reconnaissance photos would multiply. From Guadalcanal to Tarawa, from Saipan to Iwo Jima, the pattern would repeat. And each time, the same stunned realization would follow: the United States had solved a problem that Japan didn't even know could be solved. They had made war mobile in a way that turned geography, once Japan's greatest defensive asset, into something fluid, something Americans could reshape at will. But to understand how this happened, we need to step back. Before the solution came the crisis. Before the innovation came the desperation. 6 months earlier, the situation was dire. American forces were fighting a war they couldn't sustain. Across the vast emptiness of the Pacific, thousands of miles of open water broken only by scattered volcanic islands and coral atolls, Japan controlled virtually every piece of land with a usable airstrip. From the Philippines through the East Indies, from the Marianas to the Solomons, Japanese aircraft dominated the skies because they had somewhere to land, somewhere to refuel, somewhere to rearm. American pilots, by contrast, were flying missions at the absolute edge of their fuel capacity, sometimes unable to provide air support to Marines pinned down on hostile beaches simply because there was nowhere close enough to base the aircraft. Carriers helped, but carriers were precious, vulnerable, and couldn't be everywhere at once. The tyranny of distance was killing men as surely as enemy bullets. The mathematics were brutal and unforgiving. A Wildcat fighter had a combat radius of about 150 miles. Beyond that, you were gambling with fuel, gambling with lives. But the islands that needed air support were often 300, 400, sometimes 500 miles from the nearest friendly base. Even when American forces managed to capture an island, the timeline to build a traditional airfield stretched into months, months of hauling concrete, grading earth with limited equipment, pouring foundations under enemy bombing raids. At Guadalcanal, the Marines seized a partially completed Japanese airfield in August 1942, and even that, already graded, already surveyed, required weeks of desperate work to make operational. During that time, men died without air cover. Ships burned offshore. Every dawn brought another Japanese air raid while American fighters sat grounded on distant carriers or bases too far to help. The strategists in Washington understood the equation clearly: whoever could deploy air power faster would control the Pacific. Naval battles could be won or lost based on which side could project fighters over a contested island. Amphibious assaults could succeed or fail depending on whether troops had close air support within hours, not weeks, of landing. Traditional engineering doctrine said building an airfield required surveying teams, heavy equipment, weeks of preparation, tons of concrete or asphalt, and careful drainage systems. Traditional doctrine said you couldn't fight a war of rapid island hopping because you couldn't build the infrastructure fast enough to support it. Traditional doctrine was about to be proven catastrophically wrong. What the Pacific War needed wasn't better engineers following the old rules. It needed new rules entirely. It needed men who could look at an impossible timeline and find a way to make it possible. It needed builders who could work as fast as the war itself moved. They came from everywhere, from construction sites in Detroit, from oil rigs in Texas, from logging camps in Oregon. Carpenters, electricians, heavy equipment operators, steel workers. Men who knew the language of jackhammers and cement mixers, who could read blueprints and operate bulldozers, who understood that buildings rose not from theory but from sweat and precision and stubborn determination. The U.S. Navy called them Seabees, construction battalions, CBS compressed into a nickname that would become legendary. Their patch showed a cartoon bee wielding both a machine gun and a wrench, and that dual identity defined everything about them. They were builders who could fight, or perhaps fighters who happened to build. The distinction didn't matter when Japanese artillery was ranging in on your position while you operated a bulldozer. Boot camp for the Seabees wasn't like other military training. Yes, they learned to shoot, to march, to follow orders. But they also learned to repair generators under fire, to operate heavy machinery in the dark, to construct bridges while wading through swamps. The average age was higher than regular infantry, 37 years old, because the Navy needed experience more than youth. They needed men who'd already spent 20 years solving problems with their hands. Their motto captured the paradox perfectly: we build, we fight. But in practice, they usually did both simultaneously. Imagine grading a runway while mortar rounds explode 200 yards away. Imagine welding structural supports while rifle fire cracks through the jungle behind you. Imagine the mental calculus of deciding whether to dive for cover or finish securing that beam, knowing that if you don't finish, the planes can't land, and if the planes can't land, the Marines on the other side of the island will have no support when the Japanese counterattack at dawn. The Pacific Islands offered every possible obstacle. Coral that shredded equipment and tore up tires. Mud that swallowed bulldozers to their axles. 100-degree heat that turned metal tools into brands. Rain that transformed construction sites into morasses overnight. Malaria. Dysentery. Insects that seemed designed specifically to make human life miserable. And always, the threat of enemy action, snipers in the tree line, submarines offshore, bombers that appeared without warning. Yet the Seabees worked. They worked through the night using lights they knew might draw enemy fire. They worked through air raids, sometimes not even bothering to take cover because the schedule mattered more than personal safety. They worked until the job was done, because they understood something fundamental: every hour they saved meant lives saved somewhere else. Every runway they finished ahead of schedule meant fighters in the air sooner, meant close air support for troops who desperately needed it. But raw courage and skill weren't enough. The impossible timeline required something more, a technological breakthrough that would change everything. The breakthrough came from an unexpected place, not from a battlefield, but from a laboratory. Not from combat experience, but from an engineering challenge that had stumped conventional thinking. Pierced steel planking. 3 words that sound more bureaucratic than revolutionary, but that's often how innovation arrives, quietly, in technical language, before its implications explode across history. The concept was elegant in its simplicity. Take sheets of steel, stamp them with holes to reduce weight and improve drainage, punch connector holes along the edges, and create an interlocking system that could be laid down like enormous metal tiles. Each plank measured 10 feet long and 15 inches wide. Each weighed about 65 pounds, heavy enough to stay put, light enough for 2 men to carry. The holes weren't just for weight reduction, they gave traction, prevented skidding, allowed water to drain instead of pooling. But the genius was in the system, not just the individual pieces. The planks locked together with simple pins, creating a continuous surface that could distribute the weight of a fully loaded bomber across hundreds of individual panels. The engineering was sophisticated in a way that belied the apparent simplicity. Each plank had to be precisely manufactured, tolerances measured in fractions of an inch, because once you were on a Pacific island, you couldn't exactly order replacement parts. In Pennsylvania and Ohio, Factories retooled to stamp out the steel mats by the thousands, then tens of thousands, then millions. Women who'd never worked metal before learned to operate the massive presses that punched the holes and formed the edges. Quality control inspectors checked dimensions with micrometers, rejecting any plank that deviated from specification because everyone understood that a malformed edge might mean the difference between a functioning runway and a catastrophic failure. The logistics of production staggered the imagination. Each plank had to be manufactured, stacked, shipped to ports, loaded onto transport vessels, sailed across thousands of miles of ocean, unloaded at forward bases, and distributed to the units that needed them. The supply chain stretched from the American industrial heartland to coral atolls whose names most Americans couldn't pronounce. Every link in that chain had to work perfectly, because a shipment of steel planking arriving 2 weeks late might mean losing an island, or failing to support an amphibious assault, or watching aircraft circle helplessly overhead because the runway wasn't ready. But when the system worked, when the factories produced on schedule and the ships arrived intact and the Seabees received their supplies, the results were almost magical. A beach that was impassable mud one day could support C-47 transport aircraft the next. A coral flat that would have taken 3 months to convert using conventional methods could be operational in 3 days. The Americans had essentially created instant infrastructure, packaged in steel and ready to deploy wherever the war demanded. The theory was sound. The manufacturing was in place. Now came the real test: could it actually work under combat conditions? Could these steel mats, designed in American laboratories, really transform how the Pacific War was fought? Guadalcanal would provide the answer. August 7, 1942. Marines storm ashore on Guadalcanal, securing a partially completed Japanese airfield. The captured runway becomes their lifeline, but it's barely functional, rough, incomplete, and under constant bombardment. The Seabees arrive with a different vision of what's possible. While Marines hold the perimeter, the construction battalions unload their equipment and those precious steel planks, hundreds of them, thousands of them, stacked and ready. The race against time begins immediately. Traditional airfield construction would have required massive grading equipment, drainage systems, proper surveying. The Seabees had some of that, but not enough and not enough time. Instead, they improvised with the steel matting, using it to create a functional surface over terrain that would normally be impossible. Bulldozers scraped rough grades while other teams laid the interlocking planks behind them, working section by section, building the runway in segments that grew like a steel carpet being unrolled across the island. The Japanese bombed them constantly. Washing Machine Charlie, the nickname for the nightly harassment raids, dropped bombs that cratered the runway, forcing repair crews to work in darkness, replacing damaged sections while the next attack approached. Some nights, the Seabees would repair the same section 3 times, always racing against the dawn when American fighters would need that runway to launch. Sleep became a luxury measured in minutes. Men worked until they collapsed, then worked more. The statistics tell part of the story. Henderson Field, as the Americans named it, went from captured Japanese runway to fully operational American airbase capable of handling fighters and dive bombers in under a week. But statistics miss the reality, the exhaustion, the fear, the determination that bordered on obsession. And then, on August 20th, the payoff. The first American aircraft, Marine fighters, landed on Henderson Field. Pilots climbed out of cockpits and stood on that steel matting, probably not understanding or caring about the engineering marvel beneath their boots. They only knew that they had a place to land, to refuel, to rearm. They could now defend the island from something other than carrier decks hundreds of miles away. The effect was immediate and devastating for the Japanese. American fighters based at Henderson began intercepting Japanese bombing raids, turning what had been one-sided attacks into deadly aerial battles. The logistics of the campaign shifted fundamentally. The Americans now had a forward operating base that could support sustained air operations, and they'd created it faster than Japanese commanders thought possible. In Tokyo, intelligence officers examined reconnaissance photos with mounting concern. The American airbase at Guadalcanal had appeared with shocking speed, but perhaps it was an anomaly, perhaps the captured Japanese runway had made it easier. They didn't yet understand that Guadalcanal wasn't an exception. It was a template. The captured steel planks arrived in Tokyo carefully packaged, treated almost reverently. Japanese engineers gathered to examine these pieces of American manufacturing with the same intensity that cryptanalysts might study enemy codes. What they found troubled them deeply, not because the technology was incomprehensible, but because it was brilliantly simple. The pierced steel design wasn't revolutionary from an engineering standpoint. Any competent metallurgist could understand the stress distribution, the weight calculations, the interlocking mechanism. The genius wasn't in complexity, it was in the systematic thinking that turned a simple idea into an deployable weapon system. Japanese engineers had designed magnificent structures, bridges that defied gravity, fortifications that could withstand enormous punishment, concrete runways built to last decades. But they'd been trained to think in terms of permanence, of craftsmanship that would endure. The American approach was almost philosophically opposite: build it fast, use it hard, abandon it if necessary, then build another one at the next island. Reports filtered back from multiple fronts. An airfield appeared on Espiritu Santo. Another on New Georgia. Then Bougainville. Each one constructed at speeds that seemed impossible according to traditional engineering timelines. Japanese commanders found themselves fighting an enemy that could establish air superiority almost immediately after landing, before defensive preparations could be completed. The cultural dimensions were as important as the technical ones. Japan's military tradition emphasized the craftsmanship of permanent fortifications, the honor of creating structures that would stand as monuments. The American approach felt almost disposable by comparison: stamp out millions of identical steel mats, ship them wherever needed, bolt them together, use them until the battle moves on. There was no art in it, no craftsmanship in the traditional sense. Just brutal industrial efficiency applied to the problem of projecting power across an ocean. Some Japanese engineers grasped the implications immediately. One officer's report, later discovered in captured documents, was remarkably prescient: the Americans have solved not the problem of building better airfields, but the problem of making airfields themselves obsolete as strategic bottlenecks. They can create infrastructure faster than we can destroy it. That was the nightmare scenario: an enemy that could regenerate its capabilities faster than you could degrade them. An enemy whose industrial base could produce steel matting faster than bombers could crater it. An enemy that had turned time itself into a weapon. But even understanding the problem didn't mean Japan could match the solution. 3,000 miles from Guadalcanal, in cities most Americans couldn't find on a map, the real war was being fought with different weapons, with stamping presses and assembly lines, with steel mills and quality control inspectors. Detroit, already transformed into the arsenal of democracy, added steel runway matting to its endless production lists. Factories that had made automobile parts now cranked out planks by the thousands. The rhythm was hypnotic: sheets of steel fed into massive presses, the bang of hydraulics as holes were stamped and edges formed, the clatter of finished planks being stacked and counted. Each completed unit represented about 65 pounds of American industrial might, destined for some island whose name the workers might never hear. The workforce had transformed too. With millions of men overseas, women operated the machinery that would support them. Rosie the riveter's cousins worked the steel presses, checked dimensions, bundled the planks for shipping. They might not have fully grasped how their work connected to events on the other side of the world, but they understood the urgency. Production quotas weren't abstract numbers, they were targets that directly affected whether some pilot or Marine or Seabee would have the equipment needed to survive. The scale of production defied easy comprehension. By war's end, American factories had manufactured over 2 million tons of pierced steel planking. Laid end to end, the planks would have stretched from New York to Los Angeles and back again. Stacked, they would have towered miles into the atmosphere. But they weren't stacked or stretched, they were scattered across hundreds of Pacific islands, each installation a small piece of a larger mosaic of American strategic dominance. The journey from factory floor to combat zone was itself a logistical symphony. Planks were bundled, loaded onto trains, transported to ports, lifted by cranes onto cargo vessels, and shipped across submarine-infested waters to forward bases. At each stage, men and women worked to keep the supply line moving, because a bottleneck anywhere meant delays everywhere, and delays measured in days might translate to casualties measured in lives. This was modern warfare's hidden dimension. The bombs and bullets, the tactics and heroism, those grabbed headlines. But underneath, sustaining everything, was an industrial machine of staggering sophistication. Steel that began its life as iron ore in Minnesota mines ended up as runway matting on Saipan. The chemicals that became aviation fuel started in Texas refineries and powered aircraft launched from strips in the Marshall Islands. Every physical object required for war, from the largest bomber to the smallest rivet, had to be conceived, designed, manufactured, transported, and deployed. And the Americans had mastered this industrial choreography in a way no other nation could match. That mastery, more than any single battle or campaign, would determine the Pacific War's outcome. By 1944, the pattern had become routine, almost mundane in its predictability. American forces would assault an island. Marines would secure a beachhead. Within hours, the Seabees would arrive with their bulldozers and their steel mats. Within days, sometimes within hours, the first aircraft would land. The cycle repeated across the central Pacific, through the Philippines, into the approaches to Japan itself. What had seemed miraculous at Guadalcanal became standard operating procedure. The Japanese defensive strategy, building elaborate fortifications on key islands, using distance and geography as barriers, crumbled under the weight of American mobility. It didn't matter how strong your defensive position was if the enemy could establish air superiority within 48 hours of landing. It didn't matter how carefully you'd chosen which islands to fortify if the Americans could create functional airbases on islands you dismissed as strategically irrelevant. The map tells the story. From the Gilberts to the Marshalls to the Marianas, each captured island became a launching pad for the next assault. American bombers staged through multiple temporary bases, extending their effective range far beyond what would have been possible from permanent installations alone. Fighters could leapfrog from strip to strip, providing continuous coverage as the war moved closer to the Japanese home islands. Japanese engineers, watching this unfold, could only document the systematic dismantling of their defensive perimeter. The strategy that had seemed so promising in 1941, using the Pacific's vast distances to make American counterattack prohibitively expensive, had been rendered obsolete by steel matting and construction battalions. Geography, once Japan's greatest ally, had been conquered not by defeating it but by making it irrelevant. There's a photograph from Iwo Jima, taken days after the initial landing, showing the 29 bombers lined up on a freshly completed runway while fighting still raged on other parts of the island. That image captures the essence of what American engineering had achieved, the ability to create operational infrastructure faster than the battle itself moved. The airfield was functional before the island was even secured. Each new base extended American power a bit further, tightened the noose a bit more. By mid-1945, the approaches to Japan itself were ringed with American airbases, each one built with the same steel matting technology that had seemed so miraculous 3 years earlier. The war was ending, but the legacy of those portable runways was just beginning. The surrender ceremony on the USS Missouri, September 2, 1945, marked the end of combat. But across the Pacific, American airbases remained, some still operational, others already being reclaimed by jungle, all of them testaments to the engineering innovation that had helped win the war. The Seabees' contribution was finally recognized publicly. While Marines and Navy pilots received immediate glory, the construction battalions had worked largely in obscurity, known mainly to the units they supported. But military planners understood clearly, without the Seabees and their steel matting, the island-hopping campaign would have been impossible. The entire strategic approach, bypassing strong Japanese positions, seizing lightly defended islands, establishing airfields, using those bases to support the next leap forward, depended absolutely on the ability to build infrastructure at speeds that traditional engineering said were impossible. The Pierce steel planking technology didn't retire with the war's end. Korea saw its deployment again, as did Vietnam. Engineers studied and refined the concept, developing improved versions that could handle heavier aircraft and worse conditions. The basic principle, modular, portable, rapidly deployable infrastructure, became foundational to American military doctrine. But perhaps more importantly, the approach influenced thinking far beyond military applications. Humanitarian crises, natural disasters, emergency response situations, all of these began to incorporate the lesson that the Seabees had proven in combat: infrastructure doesn't have to be permanent to be effective. Sometimes speed matters more than permanence. Sometimes the ability to deploy quickly and adapt rapidly counts for more than the ability to build something that will last centuries. There's a marker at Henderson Field on Guadalcanal, commemorating the Seabees who worked and died there. Similar memorials dot the Pacific, often overlooked by tourists focused on the more dramatic battle sites. Yet these monuments honor men whose contribution was as vital as any infantry assault or naval engagement, men who understood that wars are won not only by fighters but by the unglamorous work of building the structures that allow fighters to operate. The steel has rusted now on many of those abandoned airstrips, reclaimed by vegetation and time. But the innovation they represented, the idea that engineering could be weaponized, that time itself could be compressed through systematic thinking and industrial might, that legacy endures. The war was won in the air and on the seas, but it was built on steel matting laid by men who understood that sometimes, the most powerful weapon is the ability to build what others think impossible. And to do it overnight.